Constraints and database schemas. There are 4 different constraints which can be specified on relational databases. These are domain constraint, key constraint, entity integrity constraint, referential integrity constraints. So when coming to the domain constraint, the value of each attribute of a relation must be an individual value and drawn out of possible values associated with its domain. The value of an attribute therefore must conform to the data type associated with the domain. The next we have is key constraints and null values. So when coming to key constraint and null values, each data record which corresponds to a tuple of a relation in a table must be distinct. That means no two tuples or rows in a relation or a table can have the same combination of values for all their data items. This is because that a relation as a set of tuples has to have all its tuples distinct by definition. Every relation has at least one key by default, which is the combination of all its attributes. This is called super key by default. Any such super key therefore specifies uniqueness constraint. Such a combination representing super key may have redundant attributes, implying thereby that a more useful concept is that of a key which has not redundancy. Therefore, minimal super key, also called key, is defined as that part of super key from which any attribute cannot be removed without sacrificing the uniqueness constraints. The value of a key attribute can be used to identify each tuple in a relation. A key is determined from the meaning of the attribute. The uniqueness feature of key must continue to hold when new tuple in a relation is added. Sometimes a relation may have more than one key, in which case each of such key is called a candidate key. One such key is termed as primary key of relation. The choice of which candidate key to be primary is generally subjective and may depend on circumstances of mini world. For example, both PAN, which is nothing but permanent account number, and employee ID are candidate keys in employee relation because of being unique, but employee ID should be selected in an organization being native to the organizational environment. Then we have entity integrity constraints. So entity integrity constraint states that no primary key value can be null because it is used to identify individual tuple in a relation. Null value implies that we cannot identify such tuples or identify these as alike. A failure to distinguish them means they are duplicate. Then we have referential integrity constraint. So when coming to referential integrity constraint, while key and entity constraint are specified on individual relation, the referential integrity constraint is specified between two or more relations. Next we have operations and constraint valuations. There are two categories of operations on relational model: updates and retrieval. So the three basic types of updates are as, first one we have is insert. This operation is performed to add a new tuple in a relation. For example, an attempt to add another record of an account with data values corresponding to code name and its types to accounts relation shall be made by performing insert operation. The insert operation is capable of violating any of the 4 constraints discussed above. Then the second thing we have is delete. This operation is carried out to remove a tuple from a relation. A particular data record from a table can be removed by performing such a operation. The delete operation can violate only referential integrity if tuple is being removed is referred by foreign key from other tuples in the database. Next thing we have is modify. The operation aims at causing a change in the values of some attributes in existing tuples. This is useful in modifying existing values of an accounting record in a data table. Usually, this operation does not cause problems provided the modification is directed on neither primary key nor foreign key. Whenever applied, these operations must enforce integrity constraints specified on relational database schema. Retrieval operation on relational data model does not cause violation any integrity constraints. Then we have designing relational database schema. The rules or guidelines required to design the relational database schema attempts to provide a step-by-step procedure that transforms ER design into relational data model design to constitute the desired database. In the context of ER model, following specific steps are required to cause its transformation into relational database model. The first step was create a relation for every strong entity. So for every strong entity type in ER schema, a separate relation that includes all the simple attributes of that entity is created. Either choose one of the key attribute of such an entity as the primary key of this relation, or choose a set of simple attributes that uniquely identifies this entity as the primary key of the relation so created. The second thing we have is create a separate relation for each weak entity type. So every weak entity has an owner entity and an identifying relationship through which such weak entity type is identified. For every weak entity type, a separate relation is created by including its attributes. The primary key of this new relation is the combination of its unique attributes for a particular tuple of the owner relation along with primary key attribute of such owner relation. Then we have the third thing, which is identify entity types by participating in binary, which is 1:n relationship type. So identify the first relation on n side of relationship and second one side of such relation. The primary key of second relation should be included in first relation as a foreign key. For example, an employee can authorize a number of vouchers. It implies that vouchers entity participates in authorized by relationship on n side, while employee entity participates in same relation on one side.